Okay, I recently built a brand new computer using one of AMD Ryzen 7's latest processors. You can see here I've got a 3700X, which is an 8-core, 16-thread processor. I loaded it up with 32 gigabytes of pretty quick DDR4 RAM, and it's got a really fast SSD that uses the new PCIe 4 Generation 4 standard. So it is able to read data off the disk very, very fast and process it. But I wanted to show quickly how our Didget management system on this really fast computer will handle large data sets. So you can see I've created a pod here, and I put 152 million digits in this. So I imported a bunch of files, and then I just added a bunch of test digits to this to get all the digits in there. So if I come over here to my query tab and I say, let's say I want to find all the photos. Let's take off the filter and find all the photos. It's going to sort through the 152 million digits to find everything that was a photo. And roughly a tenth of them were, so 15.2 million of them it found. I can sort by the block size to find out the ones that really have data in them from the files I imported. Again, I can filter. So if I want to just find the ones that actually have names associated with them, so they were part of a file, I hit the filter, and so it'll look at these 15 million and find out which ones have names, which were the original file names added as tags. So we can see that only 3,800 of them were like real files that I put in here. You can select them all and view them. I'll quickly pull them up and show you all the different photos. I'll let you scroll down and see them. So even with 152 million digits in this pod, I can quickly find all, if I want to find all the multimedia, which is all the photos, the videos, the audios. I should get about 45 million of them. Just going to look through. Sure enough, 45.6 million. Some of them are audio, some are video, some are images. Let's quickly go over and show you on the database tables. I've created some pretty large database tables. I have a 5 million row customer table and the Chicago crime data, which has like 7 million crime reports. And I imported them over and over again. So I took this 5 million and poured it 5 times on top of this table, so I ended up with a 25 million row table. But quickly we can come and let's say we want to find all the thefts that happened in an apartment in 2010 in the afternoon. So if I just double click there, this is going to pull up out of 21 million rows in this table. It's going to find all the rows where the primary type was theft. The date happened in the afternoon. An arrest was made in an apartment after the year 2010, or in the year 2010. Let's look at that. Years greater than, so after 2010. So here you see it found 1,893. So again, did a query. It just took a few seconds to sort through a ton of data. If we want to see locations on the street in area 12, so we can just click on that, and sure enough, we found 9,000 rows. Again, this is against a 21 million row table. Just like with normal, size tables, we can quickly drill down and find you data. So let's pull up the 5 million row table. Let's say we want to find everybody in Alaska. It found the 98,000 that were in Alaska. I'm going to find Salt Lake City, Alaska, which there probably isn't a Salt Lake City, Alaska, but there were 85 rows in this table where that happened. You'll see if we sort by the address, we get unique because all these addresses were only imported once. But if I go over to my 25 million row table where everything is imported 5 times, and we drill down and we find, say, Wisconsin, in Raleigh, so there's 410, but we sort by the address. We should get 5 for each one. Sure enough, there are 5 for that address, 5 for that address, because we imported the data 5 different times. So you can see that with this really fast processor, we're able to handle, very, very large tables and do lightning fast queries against them. Just wanted to update and show you with the new processor how much faster things happen. Thank you very much.